Okay, so we want to check if reduces to is an equivalence relation. So we need to understand what an equivalence relation is. So we need to say that basically that we say that, we have some relation between two matrices or two numbers or two people, some definition for when two things are in relation to one another. Like the example I typically give is the idea of having exactly one shared set of grandparents, exactly one set of grandparents, the same, and they got to be exactly the same. And we can call that relation cousins, right? So A is a cousin, A is related to B if they share exactly one set of grandparents. And you can see, if you take your time, that this is not an equivalence relation because it needs to satisfy these three things. It needs to be reflexive, symmetric, and transitive. And these are just words. Let's go through what each one means. So reflexive means that A must be related to itself. Symmetric means that if A is related to B, then B must be related to A. And then transitive says that if A is related to B and B is related to C, then A is related to C. Okay, now let's understand with cousins, right? So does a person have at least, okay, so I want it to satisfy reflexive. So does a person have at least one set of the same grandparents as themselves? Yes. Okay, every person has at least one, shares their own one set of grandparents with themselves. And now you could say for symmetric, if I have the same, if I have at least one set of grandparents as person B, then person B must also have at least one set of grandparents, one pair of grandparents with me. And now here's where you can see that this is not an equivalence relation, because you have, if person A shares a set of grandparents with person B, and person B shares at least one set of grandparents with person C, then it is not the case that person A must share at least one pair of grandparents with person C. And, just take your time with this. But you should see that reduces to when it comes to matrices. So now if we, broaden our set to the idea of matrices, does A reduce to itself? Yes, A reduces to itself after 0 row operations. So you're done with reflexive. Now you want to check symmetric, okay? If A reduces to B, right, can we reduces to B, right? Then B reduces to A because row operations are reversible from the previous lemma. So from 1.5 lemma, B reduces to A from 1.5 lemma. We know that row operations are reversible. So if A reduces to B in some number of row operations, then B will reduce to A by reversing all the row operations. And then you can say that if A reduces to B in K row operations, and then B reduces to C in N row operations, then indeed it's the case that A will reduce to C in at most K plus N row operations. And this is the proof that reduces to is an equivalence relation on the set of matrices.